Prime numbers are numbers that can divide by 1 and itself only. Let's have a look at two examples of a number that is prime and a number that is not prime. So I've got a number over here which is 7, and I've got a number here which is 8. If I write down the factors of 7, which is like 7 times 1, that's called a factor, right? So factors are numbers which multiply to get to that number. And if I write down the factors of 8, I can get 4 times 2 or 4 and 2. I can also get 8 times 1. So what you notice is the difference between these two is that for 7, it's a number that is divided by 1 and itself only. And so this number would be prime. 8 does have 8 times 1, but it also has 4 times 2, so it's not alone, right? So there is another two factors other than 8 and itself. So for this one over here, we're saying that these numbers are not prime. And we call this a composite number. All right, let's have a look at another example. Let's look at a few numbers. Let's get some random numbers. Let's say I got 12, 87, 101, 9, and 3. Now, if I look at each of these numbers, I need to figure out if they're prime or not. Okay? The only way they will be prime is if they have only the only factors that numbers that would divide into it would be itself and 1 only. Right? So 12, for example, can be 12 times 1, but it can also be 6 times 2, and it can also be 4 times 3. So we know this is not prime. Right? This is not prime because it's got more than just 12 times 1 as factors. Okay. 87 now. 87, can it divide by any number? 87 is a bigger number. Let's test it. Let's see if we can we divide 87 by 2. No, because this is an odd value, right? So it can't divide by 2. Can it divide by 3? If I put 3 into 87, 3 goes into 87 2 times, right? Remainder, 3 goes into 8 2 times, and the remainder will be 2, making 27, and 3 goes into 27, 29. So we can say 3 times 29 is 87. And also, 1 times 87 is 87. So this is also not prime, because prime numbers only have that factor, and not the others. This is not prime. But 101. Let's see, can we divide 2 into 101? No, because that's an odd number. Or maybe we can divide by 3. Can 3 go into 101? Let's test it. 3 goes into 1, it can't. 3 goes into 10 3 times. Remainder 1. 3 goes into 11, I can't. Right? Because it's going to have a remainder. It will go into there 3 times, and then we'll have remainder 2. So it doesn't divide by 3. It can't divide by 4, because 4 is an even number. It can't divide by any even numbers, because it ends in an odd number. Can it divide by 5? No. Multiples of 5 either end in 0 or 5, like 20, 35, etc. This would be 100 or 105 if it is 5. Can 6 go into there? No, it's an even number. Can 7 go into there? Let's try 7. 7 goes into 1, it can't. Goes into 10 once, remainder 3. 31, 7 cannot divide into. Alright, 7 goes into 31. 4 times 7 is 28, and the remainder will be 3. 8, no. 9, no. Maybe 9, let's try 9. Can 9 go into 101? 9 goes into 1, remainder 1, and 11. 10 can't. 11, 11 times 11 is 121. 12, no. 13. Can 13 go into 10? No. Can 13 go all the way into 101? So By the looks of it, as I'm trying all of these numbers manually, we want to know, is 101 a prime number? And the answer is yes, it is a prime number. Because 101 can only divide by 101 by itself and by 1. So for this one, we're saying definitely is going to be a prime number because it's going to be 1 times 101. The only factor for this one is prime. Let's have a look at 9. 9 can be 3 times 3, but it can also be 9 times 1, so not prime. What about 3? 3 can be 3 times 1, but that's definitely going to be prime. So if I want to find all the different prime numbers, right, I can basically use a method of maybe elimination, and then from there I could basically do that, right? But if I have to go through all the different prime numbers, so let's start with the first 20 numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. All right, I'm gonna circle out now. Let's see. Number one is not a prime number. All right, number one is not a prime number. Okay, so is one a composite number? And that's another question. And remember, composite number is a number that does not divide. So one is not a composite number and it's not a prime number. All right. So one is very special. So two is a prime number. I'm going to circle all the primes because it's 2 times 1. 3 is a prime number because it's 3 times 1. And 4 is also a prime number because it's going to be 2 times 2 or 4 times 1. And then 5 is a prime number. 6 is not a prime number. 7 is a prime number. 8 is not. 9 is not. This is 4 times 2. This is 3 times 3. This is 2 times 3. This is just 5 times 1. There's no other factor involved in it. Does this make sense? Yeah? And 11 will be 11 times 1. 13 will be 13 times 1. 17 will be 17 times 1. And 19 would be 19 times 1. So those will be all my prime numbers that I can see. The other numbers are composite numbers. They're known as composite numbers. All right. So that's just a quick idea of prime.